Good morning, dear students. In today's class, we'll see the problems on directional derivatives. So, we have seen the concept previously as how to find a unit vector normal, and in similar way, though here, so in the directional derivative, so they will give a curve and the point and one direction. So, with the help of these three cases, we are going to find a problems based on what here directional derivative. So, the given question, find the directional derivative of x square yz plus 4xz square at the point 1 minus 2 minus 1 in the direction 2I minus j minus 2k. So I have given phi, you have to take it as it is. This is a phi value, this is a point value, and this is the direction. So direction stand for, I have taken in general d is equal to, we know the formula for direction, so I have taken this. So now we'll solve the solution of this. So the directional derivative is given by directional derivative is given by del phi dot n cap. So we'll find first what is del phi, then what is n cap, later we'll apply here what happens to the directional derivative, we'll see. So now we'll find what is del phi. So del phi, so del phi is nothing but dou phi by dou x of I plus dou phi by dou y of j plus dou phi by dou z of k. So now we'll find this phi with respect to x partially. What we'll get here with respect to partially means what happens. So x square yz is constant, partial derivative of x square is what here 2x, and yz is a constant, keep as it is, plus here x term is there, so it is only 1x, so therefore x with respect to x1, so left is what here 4z square of I plus second term. So phi will partial derivative with respect to y means here x square and z is constant, partial derivative of y with respect to y is 1, so we left what here x square z, and here no y term, 0, leave it, of j plus, so dou phi by dou z, partial derivative of this phi with respect to z means what here, so both the term having z, so with respect to first term with respect to z, here what happens, we have left it x square y plus here it is z square, so it will become 4 to the 8xz of k. So we got del phi now. So this del phi we have to pass through the given point. What point they have given? So the point is del phi should pass through this point is what here 1 minus 2 and minus 1. If you pass this del phi through this point, so first term, that is coefficient of I, will become 8i. Second term, if you put x is equal to 1 and z is equal to minus 1, we will get minus j, and third term will get what here minus 10k. If you calculate, if you replace the value of x, y and z, you will get this result. So now we got the what here del phi result. Now we need to calculate n cap. So we know that n cap is nothing but vector d divided by modulus of vector d. So d is nothing but direction what they have given. So d, so that is nothing but 2I minus j minus 2k, that is d is nothing but what here 2I minus j minus 2k divided by modulus means square root of 2 square plus coefficient of j is minus 1 square plus coefficient of k is minus 2 whole square. So on simplification, so square root of this 2 square is 4, 1 square is 1, 2 square is 4, so 4 plus 4 is 8, 8 plus 1 is 9, square root of 9 is 3. So we got this result. So we got n cap. So therefore we go back here. So therefore del phi dot n cap. So del phi, what answer we got? That is 8I minus j minus 10k dot N cap is 2I minus j minus 2k whole divided by 3. So for these two brackets what we have, we need to go for dot product. So therefore whole divided by 3. So I dot I, so I first term with first term, second term with second term, third term is third term. So 8I dot 2I, it will become 8 2s are 16, I dot I is 1. So minus into minus is plus. The coefficient of j dot j is 1. So 1 into 1 is 1. So minus into minus is plus, 10 into 2 is 20. So therefore, so 16 plus 1 is 17. 17 plus 20 is how much here? 37 divided by 3 is the directional derivative for the given surface at the point 1, minus 2 and minus 1. So the next example is, find the directional derivative of f of xyz is equal to xy cube plus yz cube at the point 2, minus 1, 1 in the direction of vector I plus 2j plus 2k. So in the same way we need to work out this example also. So here they have given f of xyz means this is the value of f. So therefore the directional derivative is, I will write in short the dd. dd stands for direction derivative is given by del f, not phi, because here they have already given in the question. So I will take del f dot n cap. So we will find first what here? Del f, that is dou f by dou x of I plus dou f by dou y of j plus dou f by dou z of k. That is, we need to simplify partial derivative of this f with respect to x. So what happens here with respect to x means y cube is a constant, but differentiation of x with respect to x is 1. So here no x term, 0, leave it, of I plus dou f by dou y with respect to y. This f we need to partial derivative with respect to y, means here x is a constant, so y cube is what here? 3y square plus here y with respect to y means 1, so left is z cube of j plus dou f by dou z. So first term is 0, leave it. Second term is what is z cube means 3y z square of k. This is what here del f. So on passing this del f through the point 2, minus 1, 1. So this will become how much here? So minus I plus 7j minus 3k. If you apply y is equal to minus 3 means minus 1 cube is minus 1, minus 1 into I is minus I, and here if you simply put the value of x is equal to 2, y is minus 1 and z is 1, you will get 7, and if you put y is minus 1 and z is equal to 1, so you will get minus 3. So we got this. So therefore now we'll check for n cap. So n cap is nothing but direction, that is direction divided by modulus of direction, that is I plus 2j plus 2k divided by square root of 1 square plus 2 square plus 2 square. So again it will be I plus 2j plus 2k divided by 2 square 4, 2 square 4 and 1 square. So it is 9, square root of 9 is 3. So therefore directional derivative del f into n cap is equal to, it is del f is nothing but minus I plus 7j minus 3k dot I plus 2j plus 2k divided by 3. So on simplification we'll get this answer as, so minus whole divided by 3, so minus I dot I, so I dot I is 1, so minus into plus is what here? Minus 1. So plus into plus is plus, 7 2s are 14, j dot j is 1, leave it, minus into plus is minus, 3 2s are 6. So on simplification, it will be 7 divided by 3. So in this way the problems of directional derivative will be work out. So next example has solved, just I will explain here. So find the directional derivative of xz upon x square plus y square at the point 1, minus 1, 1 in the direction A. They have given the name of the direction A. Then if they have given, we have to use other. If they are not given, we will use D. Okay, I minus 2j plus k. So 5 they have given. It is in the form of fraction, point and the direction. Now, so as we know that we need to find del phi first in the directional derivative. So the formula is del dou phi by dou x of I plus dou phi by dou y of j plus dou phi by dou z of k. So on simplification, I have taken the form here 5 values, 5 value, 5 value. Now see here, so this is a quotient rule. So while doing partial derivative with respect to x, so both the term having numerator as well as denominator having what here, function of x. So at that time we need to apply u by v. So denominator square, so keep x square minus y square as it is. So this z is constant, I have kept outside. So differentiation of x with respect to x is 1 minus x into, so the partial derivative of this bracket is what here, 2x. So on simplification and keep this one as it is. Similarly the second term, okay, in second term what happens, x and z both are constant. So 1 upon x square minus y square. So partial derivative of 1 upon x square minus y square will go here, minus 2y upon x square plus y square whole square. You need to apply quotient rule for 1 upon x square minus y square. You will get this result of j plus third term. Okay, so third term is what here. So we have to differentiate partially with respect to z. So at that time with respect to z means x and x divided by x square plus y square purely constant. Partial derivative of z with respect to z is 1. So we got this, and on simplification we will get this simplification. So this will be z into, so if you open the bracket it will be minus times 2x square. So plus x square and minus 2x square, it will become minus x square. So therefore it will be z into y square minus x square divided by denominator of I minus this simplified plus into minus is minus 2xyz upon x square plus y square into of a whole square of j plus here x upon x square minus y square. Okay, so at the point, if you apply the point at 1 minus 1 1, so we'll get 0 of I plus 1 by 2 of j plus 1 by 2 of k. So this is del phi answer. Now we need to calculate n cap by using the given direction. So which is nothing but what here, so n cap is nothing but direction A value is nothing but what here, 1 minus 2j plus k divided by modulus of that. So it will be 1 plus 4 plus 1. So we'll get a 1 plus 1 minus 2j plus k of root 6. So by using the formula of direction derivative, that is del phi dot n cap. So this is your del phi value and this is your n cap value. So on simplification you will get the answer as minus 1 by 2 upon root 6, which is nothing, minus 1 upon 2 root 6 is nothing but required directional derivative. One more example I want to take here. In which direction the directional derivative of x square y z cube is maximum at 2 1 minus 1, and find the magnitude of this maximum. So we know that direction derivative is maximum along the normal vector, which being del phi. I have given this point already in the important points to be remembered. You can go and check. So this sentence, so maximum, when it is maximum, del phi is nothing but the maximum. So we need to find what here, del phi. So what is del phi? Del phi is nothing but dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z of k. So now we'll calculate this by using this phi. We'll calculate the first term partial derivative, second term partial derivative, third term partial derivative. We get it as, so on partial derivatives, so 2xy z cube of I plus x square z cube This is a partial derivative with respect to y, and with respect to z partially will get 3x square yz square of k. So at the point 2, 1 and minus 1 will get this first coefficient of I will become minus 4, coefficient of j will become minus 4, coefficient of k will become 12. So it is minus 4i minus 4j plus 12k. So this is what you are required direction in which the directional derivative, because del phi itself is nothing but maximum, and the magnitude of means square root of that. So 4 square is how much here? 16 plus 144, so we'll get 4 root 11 is the magnitude for the given directional derivative when the given directional derivative is maximum. So this is one of example. You just remember how to solve for the given surface what is the maximum directional derivative and what is its magnitude.